Hey class, this is lesson 5.1, chapter 5. First thing we're going to do is a little bit of review, some of the things you'll need in this chapter. We're going to be doing some construction, so here's a little reminder of how to do those. Number 1, construct the perpendicular bisector of this segment right here. To do that, we will need some tools. We will need a compass, and we will also need a straight edge. All right, and to do a perpendicular bisector of this segment, so that means we want to cut it in half perfectly. So what I'm going to do with my compass is measure a distance that's a little bit more than what I think is halfway across the line. I'll open it a little bit more. Then I'm going to draw a line right there, and also above the line. And I'm going to put my compass on the other end of the line. And if I leave the compass setting the same, I know that the lines will cross on the perpendicular bisector. Then I just need my straight edge. And I'll draw that line. And if I drew my line correctly, that should be the perpendicular bisector. So these two distances are congruent, and that's a right angle. Okay, now we want to bisect this angle over here. To do that, I'm going to start by getting two equal distances on my angle to work with. So I'm going to draw an arc, and from that arc, so I'm at equal distances right now, I'm going to draw another arc. From both of those points. And where those two meet, if I use my straight edge, I should have a straight line. And that line should be a bisector of that angle. All right. Now, we're also going to be using the midpoint formula, the distance formula, so this will be a good review. I'll do number 3, and I'll leave the other 2 for you. So first of all, let's find the midpoints. These 3 points make a triangle on a coordinate plane, and we're going to find the midpoints of the sides of the 3 sides of the triangle. So we want to find the midpoint of segment AB, the midpoint of segment BC, and the midpoint of segment AC. So the midpoint of segment AB would be, the coordinates are the x coordinates added together, divided by 2. So we're just finding the average of the x coordinates and the average of the y coordinates. And that's equal to 1, 2. And then BC, midpoint. So we're going to do the same thing. We're going to add the x coordinates together, divide by 2, add the y coordinates together, divide by 2, and that gives us the midpoint of segment BC. And then one more segment for the triangle, and that's AC. The midpoint of that would be the x-coordinates added together, divided by 2, and the y-coordinates added together, divided by 2, and that equals coordinates of the midpoint. All right, now we're going to find the side length of that triangle. So we're going to find the length of AB, the length of BC, and the length of AC. Using the distance formula, the length of AB would be the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. And that's equal to the square root of 68, which in simplest radical form is 2 times the square root of 17. The length of BC, segment BC, is the difference in the x-coordinates squared plus the difference in the y-coordinates squared, which is the square root of 116, which in simplest radical form is 2 times the square root of 29. And the length of a segment AC is the difference in those x-coordinates squared plus the difference in those y-coordinates squared, which is the square root of 80, which in simplest radical form is 4 times the square root of 5. So those are the exact values. Just a reminder of how I changed to simplest radical form. I found a perfect square factor of 68, which is 4. So I could think of the square root of 68 as the square root of 4 times the square root of 17, and the square root of 4 I can just write as 2. So it's 2 times the square root of 17. All right, I'm going to pause. No, let me do a couple more here. Finding the negation. The negation of the team won is the team lost. The negation of it is not too late is it is too late. And the negation of the measure of angle R is greater than 60 is the measure of angle R is less than or equal to 60. All right, and then I'll do one of these slope problems. Just as a reminder, slope is the difference in the y-coordinates divided by the difference in the x-coordinates, which is 12 minus 6 divided by 8 minus 9, which is 6 over negative 1, which is negative 6. All right, I'm going to pause here. And this will be the first part of lesson 5.1. The second part will be on a different video.